FastMCP 3 implements component versioning through decorator-based registration, allowing multiple implementations of the same tool to coexist under a single identifier while maintaining backward compatibility. This versioning system enables API evolution by exposing the highest version by default while preserving access to legacy implementations. The upcoming code demonstrates how to declare version tools using the @MCP tool decorator with explicit version parameters, showing both the original implementation and an updated version with enhanced parameters. We'll examine how FastMCP handles version registration and how these versions can be selectively exposed to clients. From FastMCP, import FastMCP. MCP equals FastMCP. @MCP, tool version equals 1, 0. Def process date input, SDR. Original implementation, now versioned. Return legacy process input. @MCP, tool version equals 2, 0. Def process date input, SDR options, dict none equals none SDR. Updated implementation with new options parameter. Return modern process input, options or. This code demonstrates FastMCP's component versioning pattern, where multiple implementations of the same tool can coexist under a single identifier. The pattern uses semantic versioning to maintain backward compatibility while introducing new functionality, with the framework automatically routing clients to the highest available version by default. The implementation shows two versions of process data: version 1 with a simple string parameter, and version 2 that adds an optional options dictionary. FastMCP handles the versioning through the @MCP tool decorators version parameter, creating distinct endpoints that share the same tool name. This approach enables gradual API evolution without breaking existing clients, as the framework's version comparison logic ensures the most recent implementation is served unless explicitly requested otherwise. The key trade-off here is between flexibility and complexity. Versioning allows smooth migrations and parallel support for different client requirements, but requires careful management of version components. The pattern enforces consistency by preventing mixing of versioned and unversioned components with the same name, ensuring predictable behavior when applying version filters. This design supports the common use case of maintaining multiple API versions from a single codebase, eliminating the need for separate deployments. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, providing access to the model context protocol framework's core functionality for this code segment. MCP equals FastMCP. Creates an instance of the FastMCP class and assigns it to the variable MCP. This instantiates the model context protocol framework, providing a foundation for registering tools, resources, or prompts with automatic metadata handling and versioning capabilities. The object is now ready for configuration or component registration. @MCP, tool version equals 1, 0. Decorates the following function as a FastMCP tool with version 1, enabling automatic registration with the specified version identifier. Def process date input, SDR. Original implementation, now versioned. Defines a function named process data that takes a string input and returns a string, with a docstring indicating this is the original implementation that has been versioned. The function signature shows it's designed for string processing, and the docstring suggests this is a baseline version that may have newer implementations available through FastMCP's versioning system. Return legacy process input. Calls the legacy process function with the provided input parameter, and returns its result. This delegates processing to an external legacy function, passing through the input data unchanged and returning whatever value the legacy function produces. At MCP, tool version equals to 0. Decorates the following function as a FastMCP tool with version 2, enabling automatic registration with the specified version identifier. Def process date input, SDR options, dict none equals none SDR. Updated implementation with new options parameter. Defines a function named process data that takes a required string parameter input and an optional dictionary parameter options, which defaults to none and returns a string. The docstring indicates this is an updated implementation that now includes the options parameter for additional configuration. Return modern process input, options or. Calls the modern process function with the provided input and options parameters, defaulting to an empty dictionary if options is falsy. This ensures the function always receives a valid dictionary for its second argument while preserving any provided configuration. FastMCP3's decorator-based versioning enables seamless API evolution by allowing multiple implementations of the same tool to coexist under one identifier. The @MCP tool decorator with explicit version parameters creates distinct endpoints that share the tool name, with the framework automatically routing to the highest version by default. This pattern supports backward compatibility while introducing new functionality, as demonstrated by the two process data implementations, version 1 with a simple string parameter and version 2 with an added optional options dictionary. The key trade-off is between flexibility and complexity. Versioning allows smooth migrations and parallel support for different client requirements, but requires careful management of versioned components. The framework enforces consistency by preventing mixing of versioned and unversioned components with the same name, ensuring predictable behavior when applying version filters. This design supports maintaining multiple API versions from a single codebase, eliminating the need for separate deployments.
The decorator swallows old versions whole, then regurgitates the newest one for unsuspecting clients.